Okay, we're taking a look at 9.1 question 20. And it reads, in a trial to test the effectiveness of aspirin in preventing heart disease, 11,037 male physicians were treated with aspirin and 11,034 physicians were given placebos. Among the subjects in the treatment group, 139 experienced heart attacks. Amongst those given placebos, 239 did. Use a 0.05 significance level to test the claim that aspirin has no effect on myocardial infarctions. Based on the results, does aspirin appear to be effective? So the first thing that we're going to want to identify here is the claim. And our claim is that aspirin has no effect here. And if aspirin has no effect, you'd expect to see the same percentage of heart attacks from those in the treatment group versus those in the placebo group. So that's what it means, is that the proportions we'd see in each group would be equal if there's no effect from aspirin. So they're saying that these two proportions would be equal. And I'm going to put a T there for treatment group, and I'm going to put another P there for placebo group. We've got two proportions here, so we want to make sure that we keep them straight. And as always with the claim, it's useful to write the opposite. And the opposite of equal is not equal. So now we can use this to go ahead and write our hypothesis statement. So we've got HO and HA. Null hypothesis is HO, alternate hypothesis is HA, and it's going to have the same players that we see in our claim here. And what goes between them in the null? Equal, because it's always equal in between them in the null. And then in the alternate, we need the strict inequality, which is the not equal. And then our little bit extra to help us write the conclusion, we put the R and the S there, and then we look to see which one looks most like, if not identical to the claim, and that is the null hypothesis. So down in our conclusion, we're going to talk about whether or not we have the evidence to reject the claim. So next, we want to go ahead and identify the various pieces, the tail of the test, look at the alternate hypothesis. This is a two-tail test. We also want to go ahead and look at alpha. Alpha is our significance level. And that's 0.05. And then next, we want to go ahead and identify our sample data. And we're going to have two samples here. And whichever one that you decide to list first, that's going to be your sample one. So sample one for us is going to be the treatment group. And sample two is going to be the placebo group. So for our treatment group, we had a sample size of 11,037 and the number of successes, which is a little bit weird here because a heart attack is a success, but the number of them is 139. And then for our placebo group, we had 11,034 in the sample and 239. So our sample sizes were about the same, but there does look to be a difference there. The number of hard techs in the placebo group, not quite double, but 100 more than that. But that doesn't matter. How we feel about it doesn't matter. We want to go ahead and see the likelihood of, if these two proportions were equal, of getting such results. But before that, we're going to write our rule of rejection. We reject the null hypothesis if our p-value is less than or equal to 0.05. And at this point, we're ready to find our test statistic. Since with two proportions, we use the normal distribution, it's going to be a z. And we're going to also want to find its corresponding p-value. So at this point, we're ready to go ahead and head on over to StatDisk, where we're going to go analysis, hypothesis testing, proportion 2 samples. And now we're going to go ahead and put in all of our data. So our alternative hypothesis, it was the not equal case. It's a two-tail case. Significance level, there's our alpha. That's fine at 0.05. Our first sample size was 11,037 with 139 having heart attacks. Our placebo group had 11,034 in it with 239 having heart attacks. So if we go ahead, hit evaluate and hit plot, what we see here is that our test statistic Z is -5.191. So that's more than 5 standard deviations away from what we would expect if these two proportions were truly equal to each other. And our critical values were at plus and minus 1.96. So we're definitely off in one of the tails there. When we look at the p-value, that's showing up out 4 decimal places at 0. So we can go ahead and take this back over. So -5.191 with a p-value of, for all practical purposes, 0. And we said we'd reject the null hypothesis if that was the case. So reject the null hypothesis we will. And now when it comes time to write the conclusion, there's 3 parts to this. The start of it begins with what we just did. When we reject the null hypothesis, we have the evidence. So we have sufficient evidence to, and then our next part comes from what part of the hypothesis statement represents the claim. That's what the R and the S were about. So R is for reject. So it's reject the claim that. And then the very last part of our conclusion is just going to be a literal cut and paste of what the claim was. And that's aspirin has no effect on myocardial infarctions. So that's what we'd continue with. Aspirin has no effect on myocardial infarctions. So let's kind of read back over that in its entirety. We have sufficient evidence to reject the claim that aspirin has no effect on myocardial infarction. So we're rejecting the idea that there is no effect from the aspirin. Now, the next thing would be to consider whether or not the aspirin appears to be effective. Well, the hope of the aspirin is that it would reduce the likelihood of a heart attack. And what we saw in our Z-score with it being negative is that we can now say we got statistical significance to say that the proportion of heart attacks using aspirin is less than the proportion of heart attacks in the placebo group. So we get to go ahead and say yes, not just because we rejected the null hypothesis, because our null hypothesis was that the proportion for the treatment and the placebo group were the same. So when we rejected the null hypothesis, that just says that they're different. We had to go back up to the sample information, as well as, it's going to be demonstrated by our Z-score what's going on with our sample information, that we got a lower number with the aspirin.